Here's your little bit of homework help for Unit 6, Lesson 4, Fitting a Line to Data. The first problem talks about a scatter plot that shows the number of hits and home runs for 20 baseball players who had at least 10 hits last season. The table shows the values of those 15 players. So you have the model, first thing, that's represented with the equation. Y is equal to 15 hundredths times x minus 1 5/10. Of course, that model represents this line that's drawn right along here. And then that line is our linear model. And then that value is given for all these different hits here. In the first column, the home runs that correspond with that person's hits and the predicted number of home runs that they would have. So a person with 12 hits actually hit 2 home runs. They were predicted to hit 3/10. Somebody that hit 150 or had 154 hits had 26 home runs, and their anticipated was 21 6/10 predicted hits. So both these players hit well above their predicted, but somebody who hit 22 times and only had 1 home run was predicted to hit nearly 2 home runs. So they didn't quite live up to it. This is an underestimation, whereas the other two are overestimations, which is a pretty good thing. The 145 person, that was quite a dramatic underestimation. As we look at this, we're going to use the graph. Player A had 154 hits in 2015. How many home runs did he have? So we'll take a look back up in here, and you need to find 154 hits. Talk about how many home runs, looking in the middle column. Just a quick, simple answer. How many were they predicted to have? Player B was the player who most outperformed the prediction. How many hits did player B have last season? So you're going to have to look through here, and you're going to have to take a look at how many hits they had, how many home runs they had, and their prediction of the home runs. Which one had the highest predicted value of home runs, or the highest number of home runs compared to the predicted value? So you're really looking for the over prediction from these values. Which one of these home run numbers is much higher, is higher than any of the others for the predicted home runs? And then finally, what would you expect to see in the graph for a player who hit many fewer home runs than the model predicted? Basically saying, what would you expect here on the graph for where those values would be for many home runs less than the predicted value? So less than this linear prediction. The second part of this, we have a scatter plot that compares points per game to free throws attempts for a basketball player in the tournament. The model is represented by the equation y is equal to 4 413 thousandths times x plus 377 thousandths. It's graphed here as a linear model, and your job is to do a screen capture of this right here. So take your keyboard and get that little screen capture, the shortcut on it. Mine, of course, is different on a PC. But I'd like for you to go ahead and take a picture of that right there so that you can go ahead and circle any of the points you need to that are going to represent, as we see, circle any points that appear to be outliers based on these data. So that one's quite a ways off, and others I don't see being too far off the data to really be an outlier. Once you're done with that, you're going to take that picture, go ahead and save it on your Chromebook, and then upload that picture right here. This option about saying that graph is on paper is not an option to be used. Part B, what does it mean for a point to be far above the line in this situation? Meaning, what does this point right here, far above the line, mean for this situation? And then based on the model, how many points per game would you expect a player who attempts 4.5 free throws per game to have? Look up here and find points per game, free throws, 4.5 free throws. Looking around here, come up with a value that's really, really close to an actual value there. Don't forget, you need to round to the nearest tenth of a point per game. Finally, one of the players scored 13 7/10 points per game with 4 1/10 free throw attempts per game. How does this compare to what the model predicts for this player? So you're looking for 13 7/10 points with 4.1 free throws. 4.1, that's probably this kid right here. How does this compare to the linear model that's up above with the line? Give me a good description there, giving good data about that, and that's all you got to do for your homework. Thanks for tuning in. Giving it your best. Have a great day.